Hello everyone, good morning. I am Nikunj, your physics teacher from QNI, and I welcome you all to the QNI class. How are you all?
Fine, sir.
Very good. So today we are continuing the lecture of chapter motion. Okay. So before starting the lecture, what are the prerequisites? So if we talk about prerequisites, so first one is distance and displacement that we already discussed. Second one is scalars and vectors. Okay. And the last is speed and velocity. So these are the prerequisites for today's lecture. Okay. Now if we talk about the weightage, so from this chapter approximately 10 to 8 marks question asked. Okay. And what we are going to study today? So today we are going to study about average speed. Okay. Then average velocity. Okay. Then acceleration. Okay. Now we are starting with the lecture with the average speed. But before starting the lecture, let me give you a quick recap. So we are in the last class discussing about speed. So what is the speed? Anyone? What is the speed? Anyone? What is the speed? So how fast or how slow you can cover a distance in a time is called speed. Speed is nothing but distance upon time. What is the speed? Speed is distance upon time. And we also discussed that distance is a scalar quantity. Speed is also a scalar quantity. Yes or no? And the SI unit of speed is meter per second. Is this clear? Similarly, if we talk about velocity, so velocity is nothing but displacement upon time. Displacement is a vector quantity. Velocity is also a vector quantity, and unit of velocity is also meter per second. Now today we will discuss, yes, time is a scalar quantity. Okay, time is a scalar quantity. We don't require direction to calculate time. Okay, now average speed. Average speed is the average speed of a body is the total distance traveled divided by the total time taken to cover the distance. It's called the average speed. Is this clear? Yes or no? So mathematically, average speed is total distance traveled upon total time taken. Okay. Suppose a body is going from A to B. Okay. Let's say this distance is x1, this distance is x2, and this is x3. Now, time taken to cover distance x1 is t1, for x2, t2, and for x3, time is t3. So, if we calculate average speed, so average speed is total distance, which is x1 plus x2 plus x3 upon total time, that is t1 plus t2 plus t3. And if body is traveling in a straight line without changing the direction, in that case distance is equals to displacement. In that case average speed is equals to average velocity. Okay, is this clear to everyone? Yes or no? Any doubt in this? Yes or no? Tell me, is this clear? Okay, very good. Now we will see some cases. Now the case one is when distance and time given and we have to calculate the average speed. For example, if body is going from A to B, and let's say this point is C. So the distance from point A to C is, let's say, x1, and from C to B is x2. Okay, so distance given, and also from A to C time is given, from C to B also time is given t2. Okay, so here average speed, this is equals to total distance, which is x1 plus x2 upon total time, that is t1 plus t2. Okay, so if distance and time is given, so average speed is simply x1 plus x2 upon t1 plus t2. Okay, it might be possible some more information given that from B to D, distance is x3, time is t3. So you can add here x3 and t3 and so on. Okay. So remember only thing that average speed is nothing but total distance upon total time. And also we know that speed is equals to distance upon time. Okay. Now in the case 2, if given distance and speed, okay, suppose if body is going from A to B, let's say this is C and this is D. Okay. Now distance is given. That means from A to C, let distance is x1, from C to D, distance is x2, from D to B, distance is x3. Now time is not given, but what given is speed. Let's say from A to C, speed is s1, from C to D, speed is s2, and from from D to B, speed is s3. Now we have to calculate the average speed. Again, same formula, that average speed is total distance, that is x1 plus x2 plus x3 upon total time. Let's say time taken from A to C is t1, from C to D is t2, and from D to B is t3. So t1 plus t2 plus t3. But in problem, time is not given. We have to calculate the time. We know that speed is equals to distance upon time. So from A to C, if we have to calculate time, which is t1. So from here we can write that time is equals to distance upon speed. Yes or no? And for A to C, distance is x1 and speed is s1. Okay. So t1 is x1 upon s1. Okay. Similarly, if we talk about from C to D, so from C to D, distance is x2 and speed is s2, which is t2. Okay. Similarly, from D to B, distance is x3 and speed is s3, which is equals to t3. So now we put the value of t1, t2 and t3. Okay. So this is equals to x1 plus x2 plus x3 upon total time. Now t1 is x1 upon s1 plus t2 is x2 upon s2 plus t3, which is x3 upon s3. So average speed is total distance upon total time, and we know that time is distance upon speed. Is this clear to everyone? Any doubt to anyone? Tell me. Now can we calculate average speed if distance and speed is given in the question? Yes or no? Any doubt? Is this clear? Yes or no? Okay, very good. Now we'll see case 3. Now here speed and time is given. Okay, suppose again body is going from A to B. Okay, let's say this point is C, this point is D. Now speed is given. So let's say from A to C, speed is s1, from C to D, speed is s2, and from D to B, speed is s3. And time taken from A to C is, let's say, t1, from C to D, t2, and from D to B, t3. Now we have to calculate average speed. We know that average speed is equals to total distance. Now we don't know the distance, so let's assume that from A to C distance is x1, from C to D distance is x2, and from D to B distance is x3. So total distance is x1 plus x2 plus x3 upon total time, which is t1 plus t2 plus t3. Now in the question, distance is not given. So how we will calculate x1, x2 and x3? Anyone tell me? How we will calculate x1, x2 and x3? Tell me. Kevin, Anay, tell me. Distance is speed into time. Okay. So we know that speed is equals to distance upon time. So distance is equals to speed into time. Very good. Okay. So if we calculate from A to C, so from A to C distance is x1 and speed is s1, time is t1. Similarly, from C to D distance is x2, speed is s2 and time is t2. And from D to B distance is x3, speed is s3 and time is t3. So we put these values. So x1 is equals to s1 into t1 plus x2 is equals to s2 into t2 plus x3 is equals to s3 into t3 upon total time, that is t1 plus t2 plus t3. Okay. So average speed is equals to total distance upon total time. Okay. So I hope all three cases clear to you. Yes or no? Any doubt in any case? If let's say in first case distance and time is given, in the second case distance and speed is given, and in the third case speed and time is given. All clear? Yes or no? Tell me. Okay, very good. Now we'll see what is average velocity. We know that velocity is displacement upon time, and average speed is total distance traveled upon total time taken. So average velocity will be total displacement upon time taken. Okay. So the average velocity of a body is the total displacement divided by the total time taken. Okay. So mathematically average velocity is total displacement upon total time taken. Okay. Suppose if body is going from A to B via C, and let's say from A to C distance is x1, C to B distance is x2, and body is traveling in a straight line without changing the direction. So in this case we can say that average velocity is total displacement, which is x1 plus x2 upon total time, which is t1 plus t2. And in this case body is not changing the direction and moving in a straight line. So in this case we can say this average velocity is equals to average speed. But what if I ask you that body is going from A to B? Okay, let's say from A to B distance is x. Okay, and time taken is t. Now body is going from A to B and coming back from B to A. Okay, so tell me the average velocity. Average velocity is total displacement upon total time. Yes or no? Now here initial and final position become same. So can we say that displacement is equals to 0? Displacement is equals to 0. Why? Because initial and final position become same, and displacement is final position minus initial position. So displacement is 0. So can we say that here average velocity is equals to 0? Yes or no? 0 upon something is 0. But what about average speed? Now tell me, what about average speed? Here what is average speed? Speed is total distance upon total time. From A to B distance is x, from B to A distance is also x, so total distance is 2x. Now if time taken from A to B is t, so from B to A also t, so time is 2t. So average speed is x upon t. Yes or no? Tell me. Any doubt in this? Anyone? Any doubt? Yes or no? Okay, very good. So in case the velocity of the object is changing at a uniform rate, then average velocity is given by the arithmetic mean of the initial velocity and the final velocity for a given period of time. That means average velocity is nothing but initial velocity plus final velocity by 2. Okay, so this is important, that average velocity is equals to initial velocity plus final velocity by 2 when speed is changing, velocity is changing at a uniform rate. When velocity is changing at a uniform rate, in that case we can say that average velocity is equals to initial velocity plus final velocity by 2. Okay. Okay, so if initial velocity is denoted by u, final by v, So this is equals to u plus v by 2. And remember this formula. Okay, that in case of increase in velocity is at a uniform rate, in that case average velocity is nothing but initial velocity plus final velocity by 2. Okay, now a body has a uniform velocity if it travels in a specified direction in a straight line and moves over equal distance in equal interval of time. What is uniform motion? That if body is covering equal distance in equal interval of time, no matter how small this time interval may be. Okay, clear? Any doubt in this? Yes or no? Tell me. Okay, very good. So we know that velocity is a vector quantity. Yes or no? If velocity is a vector quantity, it has both magnitude as well as direction. Yes or no? If velocity is a vector quantity, it has both magnitude and direction. So how you can change the velocity? By only changing the magnitude, or by only changing the direction, or you can change both magnitude as well as direction. Yes or no? If I ask you in how many ways you can change the velocity of the body, so you can say, as velocity is a vector quantity, it has both magnitude and direction. That means velocity depending, vector quantity depending upon both magnitude as well as direction. So if you change only magnitude, then also vector quantity change. If you change direction, then also vector quantity change. And if you change both magnitude as well as direction, then also vector quantity change. Okay, so first, if we talk about velocity, so velocity is changed by changing the speed of the body. Yes or no? Because the speed is talking only about the magnitude, not of the direction. But if you change the magnitude, velocity gets changed. Okay. And in the second case, by keeping the speed constant, but by changing the direction. Yes or no? Any doubt in this? Tell me. Anyone? Is this clear to everyone? Okay, Kevin. Very good. Now tell me, under what condition is the magnitude of average velocity of an object equal to its average speed? Everyone tell me, under what condition is the magnitude of average velocity of an object is equal to its average speed? If it travels in a straight line without taking turn. Very good. This is important, that without taking turn. In a straight line motion, if body is changing its direction, in that case we can't say that average velocity is equal to average speed. So it's important to mention that if body is just traveling in a straight line without changing a direction. So if body is traveling straight line in a straight line without changing the direction, without changing the direction. Is this clear? Any doubt? Yes or no? Okay, very good. Now next question. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? Everyone solve this question and tell me the answer. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed? What is the answer? Tell me. What is the answer? 5.33333. Okay, let's solve the question. So an object is traveling 16 meter in 4 seconds. Okay, let's say from A to B, the distance is 16 meter and time taken is 4 seconds. Again, let's say body is going from B to C, which is 16 meter, but time taken is 2 seconds. We know that average speed is total distance, that is 16 meter plus 16 meter upon total time, which is 4 seconds plus 2 seconds. So this is equals to 32 meter upon 6 seconds, which is equals to 2 into 16, 2 into 3, which is 16 by 3 meter per second, which is 5.3 bar. Yes, this is correct. Okay, any doubt? Any doubt to anyone? Tell me. Okay, very good. Now next, solve this question. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. Tell me the answer. Solve this question. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and the average velocity of Usha. Everyone solve this question. Use average speed is equals to total distance upon total time, and average velocity is total displacement upon time taken. Francis, what about average velocity? Kevin, what is the answer? Average speed is 16 meters per second. Okay, okay, we will solve this question. Any other answer? Any other answer? And what is average velocity here? Anna, what about average velocity? Okay, so suppose Usha swimming from A to B, okay, which is 90 meter. From A to B, this is 90 meter. She covers 180 meter in 1 minute. Okay, she is covering 180 meter in 1 minute. And we know that in 1 minute is 60 seconds. Okay, now she covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. That means she is traveling from A to B and coming from B to A. Okay, so if we talk about average speed, so average speed is total distance, which is 90 plus 90, 180. Yes or no? And time taken is 60 seconds. Okay, so 180 by 60 is nothing but 3 meter per second. Okay, so average speed is 3 meter per second. Yes or no? Any doubt in calculating average speed? Tell me. Okay, very good. Now we will talk about average velocity. So what is average velocity? It is total displacement upon total time. Now we know that total displacement is final position minus initial position. Final position minus initial position upon time taken. Now tell me, what is the initial position of the Usha? Usha initially is at point A. Yes or no? Again, finally, Usha come back to A. Yes or no? That means initial and final position become same here. Now, if initial and final position is same, that means displacement is 0. And 0 upon something is nothing but 0. So the average velocity is 0. Yes or no? Any doubt? Tell me. Very good. Very good. Okay. Now next. Solve next question. A car travels 30 km at a uniform speed of 40 km per hour and the next 30 km at a uniform speed of 20 km per hour. Find its average speed. Okay. Remember here time is not given. Here distance and speed is given. Okay. Calculate here average speed. Again use same formula that average speed is equals to total distance upon total time. Total distance upon total time. Okay. Now solve this question. Average speed is total distance upon total time. What is the answer? Tell me. Use the same formula that total distance upon total time. What is the answer? Anyone? Okay, let's calculate. So a car travels 30 km. Suppose car is going from A to B. Okay. Now the distance is 30 km and speed from A to B is 40 km per hour. Okay. Let's say car is traveling from B to C, but again the distance is 30 km, but speed is 20 km per hour. Okay. We know that average speed is total distance upon total time. So let from A to B, distance is x1, from B to C, distance is x2. So we can write here that this is equals to x1 plus x2 upon total time. Now time we don't know. So let's say time is t1 and here from B to C time is t2. Okay. So now we know the distance that is 30 kilometer plus 30 kilometer, but we don't know the time that from A to B how much time is taken by the body and from B to C how much time is taken, but we have to calculate. We know that speed is equals to distance upon time, so time is equals to distance upon speed. So for A to B, time taken is t1, which is equals to distance. Now distance is 30 kilometer upon speed is 40 kilometer per hour. Okay, so T1 is equals to 3 by 4 hour. Yes or no? Is this clear? Okay. Similarly, from B to C, time is T2. Now distance is again 30 kilometer, but speed is 20 kilometer per hour. So here T2 is equals to 3 by 2 hour. So any doubt in calculating T1 and T2? Yes or no? Any doubt in calculating T1 and T2? Anyone? Very good. Now put the values that T1 is 3 by 4 hour plus T2 is 3 by 2 hour. Okay, now here take LCM. So 30 plus 30 is 60 kilometer upon we can write 4. So 3 plus 2 into 2, 3 into 2 is 6. Okay, so this is 60 kilometer upon 6 plus 3 is 9 by 4 hour. Okay, so this is equals to 60 into 4 upon 9 kilometer per hour. So 3 into 20 is 60, 3 into 3 is 9. So 20 into 4, so 80 by 3 kilometer per hour. So the average speed is 80 by 3 kilometer per hour. Okay. So anyone with the answer 80 by 3 kilometer per hour? Yes or no? Any doubt in this question? Yes, tell me. Okay, very good. Now again solve next question. On a 120-kilometer track, a train travels the first 30 kilometer at a uniform speed of 30 kilometer per hour. How fast must the train travel the next 90 kilometers so that the average speed for the entire trip becomes 60 kilometer per hour? So everyone solve this question. Is this question clear to everyone? Or any doubt in understanding of the question? Anyone, any doubt in understanding of the question? Everyone is getting the question, yes or no? Okay. So given a track of 120 kilometer, so let's say from A to B, track length is 120 kilometer. Okay. Now a train travels the first 30 kilometer. So let's say from A to C, distance is 30 kilometer and the speed is 30 kilometer per hour. Now from C to B, distance is 90 kilometer, and given here that average speed for the entire trip is 60 kilometer per hour. So we have to calculate the speed of the train from C to B such that the average speed for the entire trip becomes 60 kilometer per hour. So what's the answer? Tell me, what is the answer? What is the answer? Tell me. Okay, so let's say from C to B, speed is S. Speed is S, and we know that average speed is nothing but total distance. Okay, now total distance, total track is of 120 kilometer. So total distance is 120 kilometer upon time taken. So let's say from A to C, time taken by the train is T1, and from C to B, time taken by the train is T2. So time is T1 plus T2. Now we have to calculate the time. Okay. Now again we know that speed is equals to distance upon time. So time is equals to distance upon speed. Now to calculate T1, we have to put the value of S1, which is nothing but 30, and the speed is 30 kilometer per hour. Okay. So sorry, this is 30 kilometer. 30 kilometer. Okay. So this is equals to 1 hour. So T1 is 1 hour. Similarly for T2, distance is 90 kilometer, but we don't know the speed. So let's say speed is s kilometer per hour. So T2 is 90 by SR. Yes or no? Now put, so average speed given is 60 kilometer per hour. This is equals to 120 upon T1 is 1 plus T2 is 90 by S. Okay. Now we can cross multiply. So this is 120 by 60 is equals to 1 plus 90 by S. Yes or no? Okay. So 120 by 60 is 2. So 2 is equals to 1 plus 90 by S. Yes or no? Any doubt? Here 90 by S is equals to 2 minus 1, which is 1. So S is equals to 90 kilometer per hour. Okay. So to maintain the average speed 60 kilometer per hour for entire trip, train has to travel at a speed of 90 kilometer per hour from C to B. Okay. Any doubt in this? Anyone getting the answer? Yes or no? Anyone with the answer? 90 kilometer per hour? Yes or no? Tell me. Yes or no? Francis. Kamalan, Anne, Kevin, anyone with the answer or any doubt in this question? Yes or no? Are you getting the answer or not? Yes or no?
Sir, I can't get the last part alone.
From where?
2 equal to 1 plus 90 divided by S equals to 90 by S. I don't know. I can't get that.
Okay. Don't get confused here. Look. So are we clear till here that 2 is equals to 1 plus 90 by S? Any doubt till this step? Any doubt till this step? Okay. Now if we take 1 to the left hand side, so this becomes 2 minus 1 is equals to 90 by S. Yes or no? T2. Okay. We know that time is equals to distance upon speed. Yes or no? And let's say from C to B, we know that distance is 90 kilometer, and I'm assuming the speed of the train from C to B is S kilometer per hour. So speed is S kilometer per hour. So from here can we say that T2 is equals to 90 by SR? Yes or no? Okay. Any other doubt? So average speed is total distance. So the total track length is 120 kilometer per hour. Sorry, 120 kilometer. And time taken from A to C is T1, from C to B time is T2. So just put the values. In question given that average speed is 60 kilometer per hour. Okay, 60 kilometer per hour. Total length is 120 kilometer. T1 is 1. How? 30 by 30 is 1. And T2 is 90 by S. So 90 by S. Now you can cross multiply here. Look, this 1 plus 90 by S multiply here, left hand side, and take 60 here on the right hand side in the denominator. Okay. So from here we can write 1 plus 90 by S. This is equals to 120 by 60. Yes or no? Any doubt here? Anyone? Any doubt here? Okay, very good. So 120 by 60 is 2. So from here we can write 1 plus 90 by S is equals to 2. Now take 1 to the right hand side. So from here we can write 90 by S is equals to 2 minus 1. So 90 by S is equals to 1. Yes or no? Now we know that 90 by S is equals to 1. 90 by S is equals to 1. So we can say that S is equals to 90. Yes or no? Cross multiply here. Any doubt to anyone? Yes or no? Anyone? Kevin? Francis? Any doubt? Okay, very good. So in the today's lecture, we studied about average speed, which is equals to total distance upon total time. And we know as distance is a scalar quantity, so average speed is also a scalar quantity. Similarly, average velocity is total displacement upon total time. Displacement is a vector quantity depending upon the position, which is final position minus initial position. Okay, and then we'll solve some question. In the next class, we are starting acceleration. So please practice these questions on the platform also. Okay, let me show you platform. Okay, so you can log into platform, go on the assessment bar, click on practice. Okay, then click on custom, select science, and then select chapter motion. Okay, In this, select view topics and you can practice on selecting explore motion, then click on the practice for selected topics. Okay, yes or no? So from this topic, come by practicing 20 questions at least. Okay, everyone, yes or no? Okay, this is your homework and we will meet in the next class. Thank you everyone. Bye bye. Take care.